Hi everyone and welcome back. We are at presentation 6A and this particular session has two presentations. So there's A and B, but not to worry, neither one is super long. It's just easier to split the information up. All right, so let's get started. Don't forget your to-do list. Make sure you're reading the chapters and any articles that are posted for reading, and then completing the activities within this presentation. I'll let you review your learning objectives on your own. All right, so let's talk about systematic reviews. So systematic reviews are a process of searching, analyzing, and summarizing information on a particular topic. Systematic reviews go through a rigorous process that follows a very specific format. And this format is intended to help search for relevant information, then provides a process to synthesize and analyze the information. And the synthesis and analysis also includes a rating of the studies that have been selected to be included. The next section in a systematic review would be a summarization of the information. And then finally, the author would provide a conclusion and a direction for future researchers. The inclusion of a method section is really what differentiates a systematic review from a traditional literature review. This and the fact that there are generally accepted best practices for conducting a systematic review. And these include the use of PRISMA guidelines. And PRISMA, the acronym PRISMA, stands for Preferred Reporting Items for Systematic Reviews and Meta-Analysis. This is a copy of the PRISMA checklist. Typically, this information is submitted with a manuscript for a systematic review and is part of the peer review process. The checklist is a great way to make sure you are including all the relevant information and have thought about all the potential biases, etc., in your development of a systematic review. Take a minute to review this checklist, and a copy of the PRISMA checklist is actually posted in this session's folder. Another important part of the systematic review is the inclusion of a flowchart. The flowchart takes the reviewer and the readers through the specific steps taken by the researcher when they conduct the literature review. It will show the funnel of studies from the beginning of the search, which is generally very large, through to the final studies that are included in the systematic review, and generally this is much smaller. The flowchart is a snapshot of the number of studies included and the number of studies excluded. Excluded studies generally include a note of why they were excluded. This is a copy of the flowchart I used for one of the systematic reviews I have written. Notice that the flowchart includes all of the databases used, along with the number of potential relevant articles, and then filters the information down. Excluded studies are noted on the left-hand side, and there's a note with a reason why they were excluded. At the very bottom of the page or bottom of the flowchart would be and are listed the studies that are included with the systematic review. Rating scales are also another important element of a systematic review. Rating scales let the reader understand how the included studies compare to each other in methodological quality. Rating a study lets you know the strength of each study and then gives weight to the results. If a study doesn't meet specific methodological criteria, then the results really are not as meaningful and the study is not as strongly designed. There are many different types of rating scales. It's important to make sure that the scale or checklist that you use or that was used in the study, if you're reading it, has been tested for reliability and validity and has been used in previous research. The list presented on the slide includes just a few of the scales that you may think of using if you're deciding to write a systematic review. I have published 2 systematic reviews, and for both I used the Downs and Black checklist with a few modifications. This is actually an example of a rating scale I've used. And as I had mentioned, it's adapted from Downs and Black. Note that the studies are listed on the left and the categories against which they are rated are noted by the columns. These categories will have a symbol in them that might say Y, which is yes, meaning that that criteria within the study was met. May have an N, and that means that no, the criteria was not met within the study that's under review. And UK equals unknown, meaning that not enough information was presented in the study to draw a conclusion about that particular criteria. As you look to the right, you'll see a column that says score. So the scores from each of the categories was tallied up and then divided by the total number of categories that were present. Based on the range of the score, the study was given a rating. So that's the very last column. Generally, and how I use it, a 66.7 or greater would equal a high rating. A 66.6 through to a 33.4 is an intermediate rating, and then generally 33.3 and less would equal a low rating. So again, this rating helps us put the information into perspective. A study that receives a low rating may still have outstanding results, but the results will have less weight as the study design is weaker than, say, a study with high ratings. So, what are the steps in the process of developing a systematic review? The first step would be to develop your research question and be sure to follow the PICO statement format. Second, search the literature. So you begin to search the literature and document your search process at each and every step in the process. Next, read the abstract and title of the papers and begin to determine which studies will be included or excluded. As the number of studies are narrowed, you then are going to read the full text of the study and make sure that you're following the criteria for what you're going to include or what you're going to exclude. All through this process, you're documenting this so that when you get to the process of actually writing out your flow chart, you'll have this information to very easily pull. After this is complete, you'll want to determine the methodological quality of each of the studies that have been selected. So that's when you're going to use a rating scale. Again, you can really use any rating scale so long as it's valid and it's been tested for validity and reliability. The last steps really include synthesizing the results and then discussing possible biases of each study. At the very end of your study, or excuse me, at the very end of your systematic review, you're going to include recommendations that you are going to present based on what you found in all of these studies that you've synthesized. So a couple of additional notes about systematic reviews. Why, might you ask, should a systematic review be done by more than one person? Well, the answer is simply more eyes, or really more opinions, are better than one. Despite the use of checklists and rating scales, which are objective, really the process of a systematic review has an element of subjectivity involved. It is the researcher's subjective opinion if a study is included and if it met the criteria for the checklist or scale. A good systematic review includes several reviewers who, on their own, review the literature and then compare the results. At the comparison, discrepancies or differences in opinions are discussed and a consensus is reached. This help reduces reviewer bias. Systematic reviews also include an extensive review of the literature. So just in our literature review process, you want to make sure that you're covering things like multiple keywords, looking at as many databases as possible, talking with a reference librarian to check your research process. They are a terrific resource and can certainly help with this. You want to do a backward hand search of studies that you've selected or even studies that are excluded. So what this really means is checking through the references within those studies. And then also search relevant systematic reviews. So you may not include a systematic review in your own review, but another systematic review on a similar topic may have studies in the references that you may want to include. While systematic reviews take time, time is not on your side. A systematic review is meant to include all relevant information. The longer it takes to conduct the review, the greater the chance that there is some information you've missed or you've left out. This will result in a constant review of the literature to make sure that everything has been included. So you really want your systematic review to be conducted over a period of time, but as quickly as possible. Otherwise, you're just going to always be going back to the very beginning process and looking through the literature again, because as we know, studies are constantly being published. While a systematic review has a quantitative research or has a quantitative research element, you're developing these ratings, it is much more qualitative in design. The end result is typically a discussion of what is existing in the literature and what is existing in the research, and then you're formulating and identifying gaps. And these gaps are what you or other researchers might work on for future research. So let's take a break. And what I'd like you to do is a quick activity. So pick one of the two systematic reviews that I've posted in this session's content folder. One is Who's Calling for Weight Loss, and the other is What's Technology Cooking Up? So in looking at these systematic reviews, look at the flow chart and the rating scale and think about how they were developed. And then also, do you see any other elements that we've discussed thus far in the course? And I'll give you a hint. Both of the things that I'm thinking about start with a P. Okay, welcome back. So now we're going to talk about meta-analysis. A meta-analysis is a quantitative approach to synthesizing the results of previous studies to determine the impact of the individual studies and then the cumulative effect. These studies determine the effect size. Effect size is the estimate of the magnitude of the difference between groups or the effect of the intervention. Just because this has a study has a statistically significant finding, it isn't guaranteed that that result will have a large impact. When effect size is calculated, it helps determine the impact or the magnitude of the study results. A meta-analysis should include a forest plot, which shows the outcome and effect size for each study so they can easily be compared. Small squares represent the relevant outcome for each study. The size of the square represents the weight of the study and the sample, or the size of the sample. Typically, the results of a study that are larger are more valuable than those that rely on smaller sample sizes. The confidence interval is represented at the bottom of the chart, and the center line indicates no difference in risks between groups. Interpretation of results to the left or right vary based on what is being studied, but they actually represent the relative risk or the confidence interval of that particular study. You may be thinking, what is relative risk? Well, simply, it is a probability assessment. It's the probability of developing the outcome in the exposed group compared to the non-exposed group. A relative risk less than 1 means the event is less likely to occur in the intervention group than the control. A relative risk greater than 1 says the opposite. It's more likely to happen in the intervention group than the control. If the relative risk equals 1, then there's really no difference between the group, and that's the center line on this forest plot. Overall, the forest plot provides a great visualization of how the studies compare. A meta-analysis may also include sensitivity analysis. Comparing results based on methodological differences is important as it can really show the effectiveness. The example your book talks about on page 376 relates to the data discussed in the previous slide. The researchers determined that there were 3 studies that used concealment of allocation, meaning the participants and researchers didn't know who was in which group. There were 11 studies where concealment was not strong. Based on sensitivity analysis, the researchers were able to show that the results in the studies with concealment showed less risk of clinical failure in patients with respiratory tract infection with the use of, and I have terrible pronunciation, azithromycin. They showed that there was a reduced relative risk. The studies that did not have concealment showed a greater relative risk. The authors concluded that the studies that were stronger methodologically showed better results, and this really adds weight to those studies and the use of the drug as a treatment. So for your next activity, I'd like for you to try to find a systematic review and a meta-analysis related or somewhat related to your research topic. Review the studies and determine if they follow the steps described in this presentation and reviewed in your book chapter. For the systematic review in particular, try to determine what rating scale was used and if it's a valid and reliable method. This is where I'm going to end this presentation. Again, be sure to read the book chapters and complete any of the assignments and the activities that are due for this session. If you have questions about anything, do not hesitate to contact me as soon as possible. Talk to you all soon. Thanks.